Welcome back to the deep dive, where we cut through the noise and deliver the essential knowledge you need,
Today, we are really wrestling with, I think, the most fundamental question driving enterprise AI adoption.
which is how do we
Mhm.
actually measure the intelligence, the real IQ
Yeah.
of these advanced AI models?
It's the big invisible barrier. I mean, we have dozens of specialized AI benchmarks, but corporate decision makers, your CFOs, your CEOs, they need a single authoritative metric.
Something simple.
Something simple that compares an AI's problem-solving ability not just to other AIs, but, and this is crucial, to their best human employees.
Exactly. This is all about business leverage. I mean, if you run a huge legal firm or a financial advisory service, you might be looking at integrating, what, thousands of AI
It's
agents?
a massive capital investment.
Right. So how do you justify that spend unless you have some kind of IQ score that guarantees this AI is, say, a 180,
Yeah.
that it can consistently generate better answers than your top people?
And if they can prove that, I mean, prove they're significantly better at novel problem solving, that integration just accelerates overnight. We're talking billions in new revenue across all sectors.
But right now, that universal trusted metric, it's just not there.
It's missing.
So the solution we found in the source material is one of those brilliant ideas that's kind of hiding in plain sight. It draws its methodology from a field you wouldn't expect at all:
Psychology.
psychology. We're going to look at a four-pronged strategy that was first developed to measure human happiness, of all things, and apply it directly to AI IQ. It's about building complexity once to get simplicity forever. Okay, let's unpack this.
So to really get the foundation, we have to go back, way back to the late 1950s.
Yeah.
Psychologists decided they needed to study human happiness, systematically. But before they could figure out what made people happy, they first had to prove, with total confidence, how to measure it.
You can't just ask them.
You can't just ask them, or at least they didn't know if you could. They knew a self-report on its own wouldn't cut it, scientifically. So they built this really robust system to gauge it and, more importantly, to validate the method itself.
So what were these initial methods? They sound redundant, but I guess that was the point.
That was entirely the point.
Yeah.
So the first two were pretty immediate and relational. Method one was the subject self-report.
Okay, that's a simple one.
The simple one. The individual reports their happiness on a scale, say, 1 to 10. Then they did an observer report. They asked the subject's friends and family to guess on that same 1 to 10 scale how happy they thought that person was.
Right, so you get the internal view and the external view. But they went deeper than that, I take it.
Oh, much deeper. The third method was direct assessment. This meant the subjects had to answer a whole battery of detailed questions, and these were specifically designed by psychologists to really gauge happiness levels, their underlying mental state. And then came number 4, which was maybe the most indirect of all.
Which was?
Indirect assessment. This was a really extensive, long-form series of questions that were not directly about happiness at all.
Like what?
Oh, they might ask about daily habits, career satisfaction, how many people are in your social circle, that sort of thing. But they could use that data via some pretty sophisticated extrapolation to measure the person's happiness level.
Wow. Asking 4 different, sometimes conflicting sets of questions just for one answer. That
Yeah.
sounds statistically exhausting.
It is, but they had to do it. They were trying to validate the entire field of study. And the big breakthrough came when the researchers found that the results from all 4 of these very different methods,
They all lined up.
they all correlated very, very highly with each other. This high statistical correlation proved the methodology was incredibly robust. It meant these 4 separate inputs were all pointing to the same underlying truth.
So that high correlation was the psychological proof they needed.
Precisely. That verification was everything.
Yeah.
From that point on, researchers knew they only really needed to ask the person for a simple self-report.
Because they could trust the answer.
They could trust the answer as highly accurate. The other 3, more complicated methods, they were basically retired. And that's why, even today, happiness metrics are cited as some of the most robust in all of psychology.
And that is the simple goal for AI IQ measurement. You do complex correlation once with 4 very different methods so that all your future measurements can be authoritative, simple, and trusted by the enterprise.
Absolutely. But before we can just port that strategy over, we have to tackle a really crucial point about intelligence, especially AI.
Right.
We're focused on IQ, problem-solving ability. It emphatically does not measure the process someone uses to get to the solution.
We have to just set aside this inconsequential distraction, as the source calls it, that AIs think differently. And there's a perfect human example of this, the savant Daniel Tammet.
Oh, Tammet's mind is astonishing. I mean, he can multiply these enormous multi-digit numbers in his head instantly. But he is not using the multiplication method we all learned in school. Not even close. His mind visualizes numbers as shapes and colors.
Right. I've heard this. The answer just sort of, it appears to him from this visualization.
It emerges, yeah. It's a unique, non-standard cognitive process. But the result is always accurate. It's reliable.
And that matters so much for AI, because AI uses these incredibly complex, often totally opaque deep learning pathways. We can't follow the logic like a human would.
Right. An enterprise doesn't care if its AI solved a logistics problem by visualizing it as a four-dimensional rainbow.
They just care that the solution is 20% more efficient than what the human team came up with.
It's about better answers, consistently. How the AI gets there is only relevant if it needs to explain its reasoning to us. But for the core measure of IQ, the outcome, it's irrelevant.
Okay, so if we can all agree that it's the output, the quantifiable problem-solving ability that really matters, then we can apply this four-pronged strategy.
And the mission is the same as it was for happiness. Establish a strong correlation between these different measures so we can translate an AI's performance into a recognized human IQ score.
Okay, let's dig into method 1. This one tries to just bypass the whole translation problem by using the human standard directly.
That's right. Method 1, direct human testing. It's simple. You just administer standard, validated human IQ tests, think Stanford, Binet, Wechsler, directly to the AI models.
Okay, and the moment you suggest that, the immediate pushback is, that's not fair. AIs have all this training data, they can process it instantly.
And the source material basically says, yes, they do. That's the whole point. If an AI is supposed to be a superior problem solver, you have to let it use its superior capabilities.
But isn't there a risk with that? I mean, with method 1, especially in the verbal or general knowledge parts of an IQ test, does that just become a test of the AI's memory?
Right.
Are we testing intelligence or just really fast information lookup?
It's a valid concern for sure, but we have to remember how human IQ tests are built. They really try to mitigate that. They lean heavily on nonverbal parts like visual matrices.
Fluid intelligence tests.
Exactly. Fluid intelligence. They're about pattern recognition, prediction. They minimize reliance on just knowing stuff. So if an AI can use its processing power to solve those novel abstract patterns better than a human,
then that is a demonstration of superior fluid intelligence.
right, regardless of how its weird alien mind processes the data.
Okay, fair enough. Let's move on to method 2, which does need a kind of translation key. It moves from AI native tests to human IQ scores.
This is method 2, benchmark correlation. Here, we take established AI benchmarks, ones that are already focused on fluid intelligence, and we use them as the baseline.
And the two big examples are Humanity's Last Exam, or HLE, and IRC AGI-2.
That's right.
So for anyone listening who knows about LLMs, but maybe not these specific metrics, what do they actually test? Why are they so important for this?
Yeah, that's crucial context. So Humanity's Last Exam, HLE, it's designed to push AI models way beyond simple test taking. It has these complex, multidisciplinary, sometimes even contradictory questions.
It's simulating the toughest challenges, like for scientists or judges.
Exactly. It stresses complex reasoning and putting things together, not just spitting back facts. And RCAGI-2 is all about generalizable intelligence. It often uses visual and pattern recognition tasks. Its design is meant to reduce the advantage AIs get from their huge training sets.
It's trying to see if the AI can solve a pattern it has truly never seen before.
Which is the definition of fluid intelligence.
So the method itself is pretty simple then. You get a large group of humans, have them take HLE and IRC-AGI-2, and at the same time they take a standard IQ test.
Correct. And if we find that, say, humans who score 50% on HLE have an average IQ of 150, we've built a statistical bridge.
Yeah.
Once that correlation is solid, across a few of these fluid intelligence benchmarks,
Then the AIs only need to take the benchmarks from then on.
right, and the human IQ score is just automatically extrapolated. It saves a huge amount of effort.
That's powerful. Okay, now for method 3. This one moves away from standardized tests and into solving actual real-world high-impact problems.
Method 3, Nobel problem correlation. This is probably the most ambitious of the four. We give AIs the exact scientific problems that led humans to win awards like the Nobel Prize.
And we're not talking about, like, simplified case studies. We mean the actual problems that took generations of work and huge intellectual leaps to solve.
Thinking about solving the Higgs boson riddle or proving gravitational waves exist, The difficulty is the whole point.
So you're testing for world-class, novel, high-impact output.
Yes. And once the AIs do their thing, we compare their success to the measured IQ scores of the actual Nobel-winning humans who originally solved them. This gives you a working correlation between solving the hardest problems we know of and a specific human IQ score.
So that gives the enterprise a much more practical yardstick. An AI with an IQ of 170 isn't just a number. It's correlated with the kind of mind that can win a Nobel.
Precisely.
Okay, what about the fourth method? This one feels the most indirect since it's all about linguistic analysis.
That's method 4, AI proxy assessment. This one starts by finding a strong correlation between the prize-winning papers of human scientists and their own measured IQ scores.
So if a human scientist has an IQ of 165, the researchers analyze their published papers to find the linguistic markers of that intelligence level.
Exactly. The idea of the hypothesis is that high IQ leaves a measurable cognitive signature in text, a specific density of new ideas, complex sentence structure, logical organization.
Okay, I follow.
Then you train a separate specialized AI just to assess a person's IQ based only on their writing. This AI becomes your assessor.
And the final step?
You then apply this new AI assessor to the subject AIs that you're trying to measure. You feed it the content, the research, the complex answers generated by those AIs. And the assessor AI analyzes that text and gives you a proxy IQ score based only on that linguistic structure.
A purely indirect, sophisticated measure of intellectual style.
That's it.
So we've covered the whole spectrum. Direct human tests, translation through benchmarks, extreme real-world problem solving, and this indirect linguistic assessment. We have 4 totally different inputs, all pointing to a single number.
And now we come back to the beautiful simplicity of the happiness study. The final crucial step is verifying the correlation.
You compare the results from all 4 AI IQ methods, the Stanford Binet score, the HLE translated score, the Nobel problem score, and the proxy assessor score.
And if that correlation is strong, if they all point to roughly the same number, let's say 175.
Then that's the simplification that the enterprise has been waiting for.
Precisely. If that correlation holds, from then on, we only have to give AIs the standard human IQ tests, or maybe the quick translation benchmarks. All that effort was front-loaded. The resulting measurement is authoritative and simple to understand.
The need for the other 3 complex tests just vanishes.
It vanishes.
And what's important for you, the listener, to realize is that the source material really emphasizes that these methods are not some far-off theory. This work is totally within the reach of even small AI labs. But right now, it's all fragmented.
And that fragmentation is what's causing the hesitation in the market. Businesses are waiting. Establishing a reliable, robust, human comparative AI IQ benchmark is the definitive missing link.
It's the numerical proof they need to convince leadership that these high IQ AI agents will directly translate into better problem solving, better efficiency, and stronger revenue.
It's such an elegant synthesis, isn't it? Taking a highly verified process from psychology and just applying it directly to solve a core challenge in computer science.
Making AI intelligence quantifiable and understandable next to human performance.
And, this research really urges groups to take this on, and soon. Because if the happiness studies are any guide, if we really can boil down the complexity of measuring intelligence to a single, trusted number, what does that imply about the scale of the cognitive gap?
What do you mean?
What if AIs consistently start demonstrating an IQ level of, say, 200 or 300, a level that enterprises today just aren't prepared for? The question stops being if they can solve our problems and becomes about how dramatically their abilities might exceed our current benchmarks.
That vast potential cognitive difference, all captured in a single reliable number.
That's something profound for you to mull or explore on your own.